to come in future. Okay, so first question which is asked is, so you see in an OSPF network, you have a domain, that is your domain and autonomous system. And within this autonomous system, you have different areas. So you may have area 0, that is your ASBR. You may have area 1. You may have area 2. One of the questions which is asked about designated router and backbone designated router, and usually they would ask, different phrasing could be there. How many DR and BDR are there in an area? Or somebody would phrase, how many DR and BDR there in an autonomous system, of course under OSPF. And that's what you're expecting, that when you have studied the topic, you have done so many times lab, you would have figured out what it is, and then you can see as many answers as many speakers are there. But the key thing is we should always go to the basis of something we do. So we'll go and remind ourselves before answering this question, why do we make DR and BDR? So this is a question we usually already have answered, but I write it for you. Say what I'm trying to do. I'm trying to reduce the broadcast. Okay, I'm trying to reduce it. This is my aim. Oops, aim. This is my aim. Then I would say, if I want to reduce it, where it is, where broadcast happens. Then I will go to further basics. I would say, oh, broadcast happens in a broadcast domain. That happened in a broadcast domain. Then I'd say, oh, do I know the difference between collision domain and broadcast domain? What's the difference? Usually we would know what's the difference. Then I say, okay, broadcast domain, then who forms a broadcast domain? So I would say switch. Switch forms a broadcast domain. So in a broadcast domain, I have to see when DR, BDR is not there and DR, BDR there, what's the difference? So when, let's say, no DR, BDR, I have to have full mesh adjacencies. full mesh adjacencies. But if I have DR, BDR, where on a broadcast domain, what I will have adjacencies with, each router would have adjacencies with DR and BDR plus adjacency between DR and BDR. So that means wherever there is a broadcast domain, there is DR, BDR. So how many DR, BDR are there in an OSPF network? As many as broadcast domains are there, there will be DRs and BDRs. What does that mean? That means there would be multiple DRs, BDRs. There's the potential of having multiple DR and BDR in a domain of OSPF network. Then comes a question, then some interviewers, they modify the question, or they have another version of the question. They say, what is the relationship between VLANs and OSPF? So one angle of answering is, from one point of view, nothing. Because I am OSPF, deal with layer 3 addresses, not a layer 3 protocol, deal with layer 3 addresses, and VLAN deals with L2 addresses. But based on the context of broadcast domain, there is a connection. So the flip side is, there is a connection. There is a connection. How? The connection is that we can have a local area network, which is broadcast. Similarly, we can have a virtual local area network, which is also broadcast. So if I have a LAN, for going from one LAN to the other LAN through subnetworks, I'll be needing layer 3 communication. Similarly, for going from one VLAN to other VLAN, I'll be needing layer 3 communication. So when it comes to the routing needs, there's no difference between LAN and VLAN. So if you look at the modern networks, heavily relying on VLAN, so that means on every VLAN also would be DR and BDR based on the same principle, because our job is to cut down broadcast activity, and DR, BDR help us to cut down activity. So that's how we can say there's no relationship between VLAN and OSPF from that perspective, but OSPF's one of the main jobs is to reduce the broadcast. So if I reduce broadcast, when I'm dealing with LAN, same way I reduce broadcast when I'm dealing with VLANs. So that is the detailed answer of that question from my perspective. Anybody have any question related to this?
Yes, sir.
Sure, go ahead, Tamar.
Sir, you have said like the broadcast is the broadcast, the number of broadcasts is equal to DR plus BDR. Like if there are two broadcast addresses, then the DR and BDR would be the same number, equivalent, or you said it's a multiple.
No. So when I'm saying DR and BDR, so DR and BDR, let's say, okay, let me draw a topology. Let's say I have a router or one. I have switch one. Gotcha. Switch router R3. So my question to you, there may be some other routers. So there may be, you know, this is a switch network. There may be some other things in here. So potentially in this topology, how many sets of DR and BDR should be there?
If the number of routers are unknown, so then
No. So number of router doesn't matter. That's what I want to teach you. So who makes a broadcast domain here?
the switches.
Switch is making a broadcast domain, right?
Yes, sir.
Okay. So how many broadcast domains I got here?
Two.
Q. So then there would be two sets of DRs and BDR. So DR and BDR are there depending on how many broadcast domain I have, because wherever I have a broadcast domain, I should have DR, BDR if I'm in a broadcast network.
Okay, sir, got it.
So now this is a switch. Let's say if I have made kind of out of this switch, I have made VLANs. So this is my one VLAN. This is my second VLAN. And somehow I have, excuse me, I'm making in this, but anyway, it's not a part of it, but I have three VLANs. So now these three VLANs are prompting me having three broadcast domains. Now I would have three sets of DRs and BDRs. So being a DR and BDR is administered by how many broadcasts per broadcast. And some of the commentators, they also use the word segment. But segment is not like that broad, right? So I would prefer to use, for example, broadcast domain.
Excuse me, sir, you said like the set of BDR, like
Yes.
yes, sir. Sir, what exactly the set? I didn't get the word, the set of.
Set of BDR mean the DR is not alone. It is DR and BDR, and I am calling this a set.
Oh, okay, sir.
So just to emphasize, they don't happen alone, they happen in pair.
All right, sir.
Yeah. A set could be an empty set. A set may have one member, set may have two
Yes,
members.
sir.
And here
Yes,
my
sir.
set has two members.
All right, sir. DR and BDR together.